Hello everyone, my name is Asutosh Shrestha and I will be presenting on the topic of deep learning for recommender systems. So the main theme of my presentation will be that deep learning is currently the best method we have to build recommender systems. Traditionally speaking, recommender systems are based on methods such as clustering, nearest neighbor, and matrix factorization. However, in recent years, deep learning has yielded tremendous success across multiple domains, from image recognition to natural language processing. Recommender systems have also benefited from deep learning success. In fact, today's state-of-art recommender systems, such as those at YouTube and Amazon, are powered by complex deep learning systems and less so on traditional methods. So before I start my presentation, I want to go over some of the references that I have used for my presentation. I will be going through a lot of topics that might sound very new, and I should mention that I will be using lots of information from these research works. I will be including the links for each of these papers at the end of the video so you can go and take a look at them. They have a lot of detailed info. So let's go over the outline of what I will be presenting on. First off, we start with a little introduction on the topics deep learning, neural networks, and recommender systems. They're the core topics here, but I'll try to keep it short. Then we'll move on to exploring why deep learning is used in recommender systems compared to other technologies that were created and have been in use since way before deep learning techniques. We'll also go on to talk about possible downsides, and then we'll go on to cover some of the main techniques that are used in deep learning because they are really important to understand the how of this whole thing that we're discussing. We will then touch upon the topic of what it can look like in the future and what directions we should follow in order to get the best out of recommender systems. And that will conclude my presentation. So what is deep learning? Deep learnings are simply machine learning algorithms that teach computers to do what comes naturally to humans, so learn by example. They are used in so many sectors today. For example, automated driving, aerospace and defense, medical research, industrial automation, and electronics. And in each of these fields, deep learning is making huge progress. So what's so impressive about deep learning? So to sum it up in one word, I would say accuracy. Deep learning achieves recognition accuracy at higher levels than every other techniques before. Unlike a few decades ago, deep learning can now utilize the large amounts of labeled data and computing power that we have now to yield the most accuracy. If we talk about how deep learning works, then we have to talk about neural networks as well, because they are the core of deep learning. So neural networks are a series of algorithms that mimic the operation of a human brain. They are composed of three layers: input, output, and in between them, the hidden layers. So recommender systems use deep learning neural networks, which are just neural networks with multiple complex hidden layers in between the input and output layers. One interesting feature about neural networks is that it is based on hierarchical feature learning. Deep learning methods aim at learning features hierarchies with Deep learning methods can aim learning feature hierarchies with features from higher levels of the hierarchy formed by the composition of lower level features. Automatically learning features at a multiple level of abstraction allow a system to learn complex functions, mapping the input to the output directly from data without depending completely on human crafted features. So let's talk about recommender systems then. Recommender systems are just information filtering systems. You might have seen them as they are a critical part of user interaction and attraction in many industries. Some of the industries that use recommender systems are news websites, computer games, knowledge base, social media platforms, and even stock trading support systems. So every kind of system that has users would possibly use some recommendation system. Given the explosive growth of information available on the web, users are often greeted with more than countless products, movies, or restaurants. As such, personalization is an essential strategy for facilitating a better user experience. So let's talk about why deep learning and why deep learning in recommender systems specifically. So deep learning methods are capable for joint representation learning, which are end-to-end differentiable. The neural networks in deep learning are composite in the sense that multiple neuron building blocks can be composed into a single differentiable function and be trained end to end. The key advantage here is when dealing with content-based recommendation. This is inevitable when modeling users' items on the web. Let's talk about the cons of deep learning. Well, I wouldn't talk about them as cons, but as potential limitations. So the first one is interpretability. Despite its success, deep learning is well known to behave as black boxes, and providing explainable predictions seem to be a really challenging task. A common argument against deep learning neural networks is that the hidden weights and activations are generally non-interpretable and they limit explainability. However, this concern has been generally eased with the advent of neural attention models that have paved the way for deep neural models that enjoy improved interpretability. The second is data requirement. Second possible limitation for deep learning is known to be data hungry, in the sense that it requires sufficient data in order to fully support its rich parameterization. However, as compared with other domains in which labeled data is scarce, it is relatively easy to garner a significant amount of data within the context of recommender systems research. The third limitation would be extensive hyperparameter tuning. Against deep neural networks, we note that hyperparameter tuning is not an exclusive problem, but machine learning in general. Granted, deep learning may introduce additional hyperparameters in some cases. Now let's talk about some of the techniques that are used for deep learning in recommender systems. The first one is recommendation with neural building blocks. In this category, models are divided into 8 subcategories in conformity with deep learning models. They can be easily modeled and used as a recommender system. And the second one is recommendation with deep hybrid models. Some deep learning based recommendation models utilize more than one deep learning technique. So the flexibility of deep learning neural networks makes it possible to combine several neural building blocks together to complement one another and form a more powerful hybrid model. After all that, we should move on to talk about how we can improve upon deep learning techniques in the future. The first way is to include cross-domain recommender systems. We should not be thinking in terms of not being limited to one specific domain while deriving the perfect recommendation for a user. Why not explore other fields that would tell you something extra about the consumer? Using deep learning techniques, various types of data can be used as a unified input by embedding representations, constructing deep level prediction models for recommendation, so we can integrate various types of cross-platform heterogeneous data. The second one is improving explainability. Deep learning based recommender systems use deep learning model to directly predict the user preferences by using multi-source heterogeneous data. The result of the model training is to get the weights between the neurons of deep neural network. It is difficult to give a reasonable explanation directly to the recommendation results, and a recommendation that actually explains what you want is would be truly an AI experience. The third one is attention mechanism based recommender systems. Applying the attention mechanism to recommender systems can help recommender systems to grasp the most informative features of the item, recommend the most representative item, and enhance the interpretability of the model. Applying these techniques usually impacts the workings of CNNs and RNNs in deep learning models. So from all that, we can conclude that the dramatic increase in the amount of data being produced by electronic and automated devices necessitates the need for intelligent techniques and applications that can properly and intelligently store, process, access, and analyze information for maximum benefits to the users. Deep learning based recommender systems are of such leading solutions to these challenges, which are appropriate tools to quickly aid the process of information seeking. Deep learning based recommender systems can learn the latent representations of users and items from massive data, and then construct a recommendation model. Finally, generate an effective recommendation list for the user. As long as the personalization trend remains popular, the recommendation system research will play as an essential role in information filtering. Although the application of deep learning into recommender systems field promises significant and encouraging results, challenges such as accuracy and scalability are still open for improvements, and they warrant future work. So these are the links for the references that I've used in my presentation, and that's all. Thank you.